Equivalence partitioning is a software testing technique that divides a software's input data into partitions of equivalent data, or classes, from which test cases are derived. The goal is to reduce the number of test cases while maintaining test coverage by assuming that if one value in partition works, all other values in that partition will behave similarly. This method divides input data into valid and invalid groups, testing a representative value from each group to cover all variations efficiently. Implementation steps. First of all, identify input conditions or determine the requirements for the software's input fields. Divide into partitions. Group the inputs into distinct equivalence classes. These classes are typically split into valid and invalid partitions. Valid partitions. Ranges where the input is expected to be correct. Invalid partitions. Ranges where the input is expected to be incorrect. Select a representative value. Choose one test value from each partition. A. For a valid partition, a value from within the range is chosen. And B. For an invalid partition, a value that is outside the valid range but still falls into invalid category is chosen. And finally, test the selected values. Use the chosen values to create test cases. This approach significantly reduces the number of tests needed to achieve good coverage. What are the benefits of equivalence partitioning? Reduces test cases, avoids the need for exhaustive testing, saving time and effort. Maximizes coverage, ensures that different types of input, valid and invalid, are tested efficiently. Saves time and effort. Achieves effective test coverage with a minimal number of test cases. Detects bugs at boundaries. Can be used in conjunction with boundary value analysis to find bugs at the edges of partitions. The last one is very useful because equivalence partitioning is always used and often used with boundary value analysis. Now, let's take equivalence partitions examples look. Age eligibility example. The rule is a financial loan applicant must be between 18 and 60 years old to register to apply for a loan. What are our partitions? So there are three partitions here. First, invalid partition 1, ages less than 18 years old. Valid partition. Second one, any ages between 18 and 60 years inclusive. And third, invalid partition 2, any ages greater than age 60. What are our test cases? Select one value from each partition to test. For example, invalid partition 1, test with age 17, which is lower than 18. Then, second test case, where valid partition, split evenly, test with age 30. And third test case, invalid partition 2, test with age 61, which is exactly 1 year older than expected. So our expected result. The system should display an error for ages 17 and 61 and allow registration for age 30. Second example. Password length example. The rule is a password must be between 8 and 12 characters long. What are our partitions? There are three of them. Invalid partition, length less than 8 characters, valid partition, length between 8 and 12 characters, all inclusive, and third partition, invalid partition number 2, length greater than 12 characters. What are our test cases in this for this equivalence partitioning. Select one value from each partition to test. Test case number 1, testing invalid partition 1. Test with a password of length 7. Test case number 2, valid partition. Test with password of length, let's say 10. And test case number 3, invalid partition 2. Test with a password of length 13. Expected results. The system should reject password with length of 7 and 13 and accept a password with a length of 10.